In this video, we are going to be graphing two exponential functions. One is going to be exponential growth, and the other one is going to be exponential decay. So my first function, I'm going to write up here, is y is equal to 1 times 1.2 to the x power. And in order to graph this function, I'm just going to create a t-chart where I'm going to write out some x values, and then I'm going to figure out what is y equal to at that x value, and then I'm going to plot those points and create the graph out of those points. So the x values that I'm interested in are going to be 0 through 12, and I'm going to count up by 2 here. So 0, 2, 4, 6, 8, 10, and 12. And then to figure out what y is equal to at these points, I'm just going to use a calculator and evaluate with a calculator. And so for x is equal to 0, well, I don't have to use a calculator for that because I know that anything to the 0th power is going to be 1, and 1 times 1 is 1. And so y is just going to be equal to 1 whenever x is 0. And then to find what y is equal to when x is equal to 2, let me bring that calculator back up, and that's just going to be 1 times 1.2 to the second power. And so that's going to be 1.44, and I'm going to round just to the 10th here. And bring that calculator back up. When x is equal to 4, that's going to be 1 times 1.2 to the 4th power, which is going to be 2.07, which is going to round up to 2.1. And then rather than go through the calculator with each of these, I've calculated them already, and so I'm just going to write down the values. So that's going to be 2.1, and then when x is 6, y is going to be equal to 3. When x is 8, y is going to be equal to 4.3. When x is equal to 10, y is going to be equal to 6.2. And when x is equal to 12, y is going to be equal to 8.9. So now that I have these points, I can plot these points, these coordinate pairs on this graph here to figure out what the graph of this exponential function looks like. So when x is 0, y is equal to 1. And so that's right here. That's also my initial value and my y-intercept. And when x is equal to 2, y is going to be equal to 1.4. So that's going to be about right there. And when x is equal to 4, y is going to be equal to 2.1. It's going to be a little bit higher, about right there. When x is equal to 6, y is going to be equal to 3, which is going to be about right there. When x is equal to 8, y is going to be equal to 4.3. When x is equal to 10, y is going to be equal to 6.2. We're going up a little bit faster now. And then when x is equal to 12, y is going to be equal to 8.9, which is going to be about right there. And so to graph this function with the points, I'm just going to draw a line or a curve rather that goes through all of those points, which is easier said than done. But there we go, this steady upward slope. So not a straight line, it's actually curving upward, and the further we go on the x-axis, the sharper the slope of that curve is going to be. So obviously this is an example of exponential growth. So exponential growth here on the left. Of course, we can have exponential decay also, and that's what we're going to see on the right-hand side here. So the function on the right-hand side is going to be y is equal to 6 times 1/2 to the x power. So that's 6 times 1/2 to the x power. And you'll notice on the left-hand side here with exponential growth, I had a common ratio that was greater than 1. And here, what I'm going to model here is exponential decay, and that's going to have a common ratio that's less than 1. And so we're going to start with a larger number that gets smaller. And so just like I evaluated the t-chart on the left-hand side, I'm going to do the same thing on the right-hand side. I'm interested in the x values from 0 to 12, and I'll count up by 2s here. And then I'll just use a calculator just like I did before. Except I know that for this first value here, when x is equal to 0, 1/2 to the 0th power is going to be equal to 1. So that's just going to be 6 times 1. And so this is just going to be 6. And then I can use a calculator for the second value here. So that's going to be 6 times 1/2, so 0.5, raised to the second power, which is going to be 1.5. So I have 1.5 here. Oops. 1.5. And then I won't go back through the calculator. I've calculated these out off camera, so to speak. And so let me write those out. So that's going to be when x is 4, y is going to be 0.38. When x is 6, y is going to be 0.09. I'm going to take these out I'm going to round them to the 100th. When x is 8, y is going to be 0.02. And then when x is 10, y is going to be 0.01. And then when x is 12, y is going to be 0.001. So I'll take that one to the 1,000th. And then just like I did on the left-hand side, I'm just going to use these as coordinate pairs and just plot out the points on the graph here. So when x is 0, this is going to be our y-intercept. It's going to be right on the y-axis here. When x is 0, y is going to be equal to 6. And then when x is 2, y is going to be equal to 1.5, which is right about here. So I'm going to go over 2, and then I'm going to go up 1.5, so about right there. And then when x is equal to 4, y is going to be equal to 0.38, which is going to be down about right there, maybe. And then when x is equal to 6, now we're at just smaller than 1/10. And so now we're just right above the x-axis there. And then when x is equal to 8, now we're at 0.02, which is basically right on the x-axis at this scale. When it's 10, then the x-axis is going, or the y value is going to be 0.01. Which I'll just estimate is right there. And then finally, when x is 12, then y is going to be 1,000th, which is, we'll just mark that as right there, right on the x-axis. And so to graph this, all I need to do is connect these points. And so it's going to start off with this steep downward slope. And then I'm going to do my best to get it through all these points here. And then by the time we get to 12 on the x-axis here, the line is almost perfectly horizontal. It appears to be moving right in the same direction as our x-axis is moving. So on the right-hand side, we have exponential decay. It's decay because it's getting smaller. So on the left-hand side, exponential growth going up faster and faster and faster. And then on the right-hand side, exponential decay. And the further we move on the x-axis here, the shallower and shallower that slope is going to become.